You're recording already? Yes. So shall I start? Okay. So, a little bit late, but that's fine. Hello, everybody, and welcome to those in the room, and to, I think we have quite a community online now, so welcome to everybody who's joining us online. So this seminar today, which we're holding with gratitude and with pleasure at the Royal Northern College of Music in Manchester, is called AI and Practice-Based Research in Music and the Arts. And I'm just going to introduce this, and then I'm going to hand over to the most important speakers, my two composer colleagues, Artemi Gioti and Einbond. Now, this seminar is the third in a series of 4, hosted by a research program that I direct, which is called Music and AI, Building Critical Interdisciplinary Studies, or for short, the horrible acronym MusAI. And this research program is based at University College London, with a host of connections through the network that the team represents. And this series of 4 seminars, we're particularly grateful to the Alan Turing Institute, and within that the Arts and AI Interest Group, some of whom are with us today, for helping us with this series and for hosting it with us. So here are the 4 seminars, and we've had 2. The first was at the Alan Turing Institute in London and was called Re-Engineering Recommendation, Prototyping Radical Interdisciplinarities. And in that one, we presented one of the projects in our overarching program, which was about developing recommender systems on a completely new basis, using normative ideas from public service media. So the idea is recommendation in the public interest. The second seminar, which we held a couple of weeks ago in Edinburgh at InSpace, was called Music and Copyright After Generative AI, Social, Ontological, and Legal Perspectives. And that was a great event, which we were really happy to do up in Edinburgh. And by the way, the first seminar, this third seminar, and the one next week, are all being recorded, and we will be uploading them online because some people I know want to look at them. Today's seminar is the third, and I'll be telling you more about it, as will Artemi and Erin. And the fourth seminar, which is a week today back in London at the Alan Turing Institute, is called Towards Radically Interdisciplinary AI Pedagogies. And what it does is present our early ideas about turning the research we've been doing in a number of projects into new prototypes for how you might train young engineers, computer scientists, data scientists going out to work with AI. So please come along next week. It will be, again, hybrid. Now, our aim in these seminars, today too, is to present our work in progress. In fact, I think it was sent out on the list of those attending today that we've just published in the Computer Music Journal a fairly major paper on the work that we're presenting today, authored by Artemi, Erin, and less so myself. And so I hope some of you will have had a chance to look at that paper. And what we'd love to do as we get into the discussion later is think together. And this idea of thinking together in an event like this is something I actually learned in Berlin at the Metz Musik Festival, which Bernardo Polzer had a wonderful kind of idea of how to make this happen. So that's what we're trying to do. Here is the front page of our website. Just gives you a glimpse. Please go and look at it and you'll learn a great deal more about what we're doing in the program as a whole. And here is the rubric. So MusAI is a 5-year program dedicated to investigating the cultural implications of AI through critical studies examining its relationship with music. So we're taking music, if you like, as a kind of lens, a crucial lens, an important lens, through which to open up questions critically of the wider cultural effects and implications of AI. And as it says there, we're based in the Institute of Advanced Studies and the Department of Anthropology at UCL, with links to the Max Planck Institute for Empirical Aesthetics in Frankfurt, the Department of Music at King's College London, and a number of other places. And the program, we need to credit the European Research Council, which has funded this program. And we've also been very grateful to receive additional funding from the Max Planck Institute, from McGill University, from MILA, the AI Institute in Quebec, and so on. So here on this ungainly slide are all 10 of the projects in this program. Please cast your eyes over it a little bit. And the one in green is the one we're presenting today, okay, which is called Permeable Interdisciplinarity, Algorithmic Composition Subverted. And I'm sure Aaron and Artemi will explain more about that as they go. But there are, in fact, 9 projects in the opening phase of the MusAI program, and they start at the top there, a project on genre and bringing musical genre into dialogue with music information retrieval as a field, which has a rather reductive account and way of modeling musical genre, and we're interested in trying to confront that with much richer models of genre from the humanities and social sciences. Then we have a couple of projects by Eric Drott and Ollie Baun, broadly looking at the music AI startup sector, what it represents, how it works, the kinds of values, the kind of music being envisaged and produced in that sector. And then we have Chris Howarth's largely historical study of musician-engineer collaborations around earlier paradigms in AI. Jonathan Stern working on the automation of signal processing and mastering. And then below Artemi and Aaron's project, a couple of very important ethnographies getting outside the West. Darcy Sprengel, who's based in KCL Music, who's looking at the attempt to localize streaming and recommendation through the Middle Eastern platform Anhami, and what does it mean to try to localize streaming and recommendation. And then Janis Serres, who is doing incredibly interesting work among musicians and producers in Nigeria, looking at their attempts to engage with AI and the kind of virality that happens around AI there. The Recommender System project I've already mentioned, I won't say more about it, but I will talk about the second stage project at the very end of that list in blue, which is what we'll present in a week's time at the Turing Institute. And as I mentioned, this is our attempt to say we're going to take the insights generated from this broad set of research projects, and we've begun to discuss this now, and sort of turn them into interesting and powerful new interdisciplinary pedagogies that go beyond ethics, which is currently the predominant paradigm in thinking how to make AI trainings better. So that we will talk about next week. So why this research program at all? What's the rationale? Well, a very simple one in a way, which is that despite a very a rapid increase in both academic and policy work on the social and the ethical implications of AI, when I wrote this proposal to the ERC, it seemed as if there was no major research initiative yet that was examining AI's cultural implications, which, for example, are currently exploding around generative AI and its implications for creativity and cultural production. So in this context, as I said, the MusAI program takes music as the medium through which to initiate a field of critical interdisciplinary studies examining AI's implications for culture. And another way into this is that although quite a lot of funding is going to both scientific and artistic research practice in this area, if you look across what's happening, for example, at the Centre for Digital Music in London at Queen Mary, critical research on AI music is at an earlier stage. And I want to insist that by critical, I mean that we can develop new approaches in this way that feed into new kinds of AI design, like the Recommender System project, and indeed to new kinds of music making, which we'll hear about in a minute. So to achieve this, MusAI as a program suggests that we need new approaches. And those are approaches that cut across the entrenched disciplinary, methodological, and epistemological divisions that come between the, quotes, hard sciences and quant sciences on the one hand, and the qualitative arts, humanities, and social sciences on the other. We have to begin to finesse this dualism and move across that. And so one of the things we've been doing is working very closely in a sustained way with computer scientists and scientists from music information retrieval to hold these rich, sustained dialogues with artists, with musicians, with social scientists and humanists. And our aim is to prototype the new kinds of interdisciplinarity for AI music, but also for the digital humanities more generally. And then we're going to prototype that approach in the second stage, feeding into these new pedagogies and trainings. So I welcome anyone to get in touch with us, join us, come along, feed in some ideas. We'd really welcome that. And with that, I'm going to hand over to Erin, who's going to start the real stuff. Okay, thanks.
Thank you, Georgie, for that incisive introduction, and thank you to our generous hosts, both here at PRISM and RNCM, and to the Alan Turing Institute. So I'm going to present the first half of the body of this talk, and then I'll pass over to our collaborator, Artemi Gioti. And much of this talk comes from a recent publication in the Computer Music Journal. And that's out, so we do invite you to go take a look at that if you'd like to look in more depth. And I just wanted to begin by presenting the major research questions that we're going to be dealing with today, we hope, and indeed in our continuing research in the project. So Artemi and I are composers and practice-based researchers, and we were interested with Georgina in thinking about how does machine learning shape aesthetic choices in our distinctive compositional practices as case studies, and how is this in turn shaped by aesthetic commitments? How is this grounded in our aesthetic backgrounds as composers? Second, how are critical themes from humanities scholarship relevant to inform our artistic research and composition? So not only the kinds of constructive AI research that we do to build our patches and our compositions, but critical reflection on those through humanities scholarship. And finally, in what ways does interaction with ML as composers differ from interaction with other computer or music technology tools? And that's, in a way, the big question for us at the end. Is this just another type of music technology that we can examine in similar ways, or indeed is it a different paradigm that needs to be looked at and treated in novel ways? So now back to the slides. And we addressed these through two compositional case studies. So Artemi and I both composed a new work as part of the MusAI research program, and then we have been reflecting as well on the experience. And a key method in our reflection is autoethnography, which has been a growing method in both scholarship and creative fields. A number of references that we've drawn on, but also very much in harmony with Georgina Born's own work in the area, drawing on her ethnographic paradigms and examining how we can use those to inform our autoethnography. And also maintaining an open dialogue between ethnography and theory in what Georgina refers to as post-positive empiricism. So the idea is it's neither purely ethnographic nor is it purely theoretical, but the two are in a constant dialogue that mutually inform each other. And that's been a very fertile approach for both of us, for all three of us. And a key term here is the assemblage. That's in the title of our CMJ paper. So we are not thinking about machine learning algorithms as narrowly defined, but rather as part of a broad assemblage that spans the entire flow from acoustic musical instruments to microphones, loudspeakers, audio descriptors, data, code, human performers, the audience, the room, the space. All of this, we argue, is part of the machine learning assemblage, and we cannot conveniently separate out just the algorithm or just the code and treat it on its own. Along with this, one of our guiding principles, and I hope one of our contributions, is to root all of our observations in our aesthetically situated background. So we are artists as well as researchers. We come with a set of acknowledged and unacknowledged biases, backgrounds, experiences, and everywhere along the way of working with machine learning, our decision-making processes are being informed by that background. And we'd like to try to open the window shade on that and engage with it head on and not try to present our decisions as objective or opaque. And this is meant to counter what may be a tendency in science and technology studies to overlook the specific cultural, societal, aesthetic context in which technological tools are deployed and developed. We'd like to do the exact opposite. A few acknowledgements of some of our forebears, some past work that we're building upon. Of course, there's been much fertile exploration of aesthetic engagement with interactive music technology. Composers and scholars like Agostino Di Scipio, George Lewis, Jonathan Impit. But our study differs in looking through the lens of machine learning as we understand it today, in our definition, that is incorporating supervised or unsupervised learning from a training data set to inform interactive behaviors. So by that narrow definition, some of those previous artists we would not necessarily qualify as machine learning. Conversely, Rebecca Fiebrink, who is part of the MusAI project, has done very interesting work with Letitia Sonami, for example, about the aesthetic concerns of creative collaboration between an artist and machine learning tools. But once again, our study differs in that the focus here is on composition and in fact score-based composition. So although we'll be speaking quite a bit about improvisation, both of we two composers work with notated scores, and we believe that that brings a new angle to this discussion of ML and aesthetics. So the first case study is the one that I'm presenting, and it involves a composition prestidigitation for percussion and interactive 3D electronics. And it was very much a collaborative effort. I worked with percussionist Maxime Echardor, and he will appear frequently in the rest of the talk that follows. I'll be showing some images and a video shortly, but just to summarize some key points, the piece is designed around a custom-built percussion setup that we built together using bespoke instruments, bespoke objects from Maxime's studio, as well as a specialized three-dimensional microphone and a three-dimensional loudspeaker. I'll speak a little bit more about those later. And in terms of the code, the patches, there are three interacting machine learning algorithms at play in this composition. They perform an audio mosaicing task, a spatialization task based on predicting the three-dimensional radiation patterns of novel sounds or sounds novel to the training of the data set. And finally, machine learning to control a generative computer improvisation. Here's an image of the percussion setup, which you'll find on the cover of the issue of the Computer Music Journal, I'm delighted to say. And you can see some of the handmade instruments as well as instruments that Maxime gathered at different corners of the globe. Seashells he collected on the coast of Brittany, seashell chimes he brought back from Taiwan. And In the background is the eco icosahedral loudspeaker array, and I'll speak a bit more about why that is there. That's the primary electroacoustic sound source of this piece, along with the acoustic instruments. And obviously, as I've said, all of what follows is situated by my embodied aesthetic history and culture, which we claim is true for any artist working with technology. A few key elements of that background: I've been influenced by the work of Helmut Lachenmann and his musique concrète instrumentale. I refer to what I do as a kind of joke with myself as musique instrumentale concrète, which is meant to reference Lachenmann along with the field of musique concrète. I've also been very much influenced by ideas of improvisation, and in particular non-idiomatic improvisation of artists like guitarist Derek Bailey. Richard Barrett has turned that on its head, but in a way it's, I think, the same idea. He's referred to some of his work as radically idiomatic. In other words, it might appear to be going against common practice performance on the instruments of the performers, but actually in the end it's highly idiomatic because it's finding cracks and subversions within the assemblage of those instruments to exploit. And I take that to also refer to what I call radical personalization. So not only the instruments, but the specific human personalities of the performers with whom I work. I mentioned to the composition seminar earlier that I see my work as written for specific performers, and if another performer were to adopt one of those pieces, I'd think of it as a kind of cover that required reinterpretation. So I don't view these works as transferable the way that a string quartet might classically be considered. So I'm going to begin now with an excerpt from a performance of the work. This was part of a concert that was organized by the MusAI project a couple of years ago at dearly departed venue Eclectic in London. The title of the event was Performing Critical AI. And you can find the full YouTube video, the full video on both the MusAI website and our YouTube channel. So please do go and listen to the entire performance later if you would like. I recommend using high quality headphones if you can, because it's based on a binaural rendering of the spatial electronics. So I'll now play just about the last 5 minutes of that roughly 15-minute piece. So that's the end of the work. And thank you. So now I'll be outlining three themes drawn from critical themes drawn from humanities scholarship that came out through the process of making and then reflecting on that composition. The first is that as in the process of making the work, I was drawn to the work of anthropologist Lambros Malaforis and his concept of material agency and material engagement. And this, to me, spoke to the autoethnographic reflections on what it was like to collaboratively compose this piece, not only with Maxime, but in a sense, collaboratively with the machine learning assemblage, the push and pull that went back and forth between composer, performer, and technological tool. In Malaforis' formulation, he speaks about pottery. At one moment, movement is effortless and feels like happening to the potter, rather than being done by the potter, as if totally absorbed in the microstructure of clay. At another moment, the potter is clearly conscious of moving clay around and shaping it, directing the flow of the clay and struggling to control the act and handle the clay. And he elaborates that material agency is not a property either of humans or non-humans. It's the emergent product of the engagement between the collaborators. It's something that becomes realized through that process. Here's some image of the potter and clay from Malaforis. And this particularly spoke to me as I thought about the experiences that Maxime and I had in the studio, testing bits of patch, testing bits of score, adjusting parameters, going back and listening again, testing again. Something that when I describe it sounds like it could be fairly reflective, but actually in the room, in the process, feels immediate. It's something that, in the words of another scholar, Searle, could be referred to as intention in action, non-deliberate everyday activity where no intentional state can be argued as being formed in advance of the action itself. So for anybody in the room who's edited a max patch in the heat of a rehearsal or performance, that seems to me a very accurate description of the feeling. I don't have time to think, all right, I'm going to change this parameter. What should it be? I'm not sure. My fingers kind of walk to the keyboard. The numbers change. I press go. Maxime reacts. Even more obviously, his reactions also are very much not premeditated. He listens. He makes immediate adjustments to what he's doing with his percussion instruments. And there's a further level where I, as the ersatz audio engineer in this case, have my fingers on the faders at all times. I'm also listening and making adjustments to the output levels, making adjustments to the premix and the patch. And all of this is not something that I feel I reflect on in advance. The terminology also echoes Pickering, or his earlier work where he describes the dance of human and non-human agency. And that's another powerful metaphor that I kept coming back to and thinking about my experience making this piece. And so as I've been saying, Maxime, the percussionist, the computer and its technological assemblage, and I all are engaged in this push and pull between human and non-human agents, reacting, listening, making adjustments, reshaping. Very much, it feels to me like the potter and her clay. So this brings us to some of the key research questions. That's all very well, but doesn't this apply equally to music technology without machine learning? And indeed, it absolutely does. One beautiful example is an article by Georgina Born and Joe Snape, in which they look at the work of composer and improviser Mark Fell using Max, the same computer program that I used to realize my project, but without machine learning in the traditional sense. And indeed, there's a clear dance of agency going on in the work of artists like Mark Fell and many others. But I argue that when ML is in the picture, the agents become even more decentered, even more unpredictable, even more contingent, not only on the immediate inputs and outputs in the performance, but also on many steps that preceded that. The step of training the machine learning agent, which happened at some earlier time period. The step of recording the samples that we use to make the audio database that was used to train the machine learning agent, which happened several months before, and so on and so forth. So the condensation of all of this artistic labor and all of the situated aesthetics that went into that all goes into the experience of material engagement with machine learning. We also would argue that the decentered nature of these actions is sometimes overlooked in conversations about machine learning. There's a little bit of a tendency to not look inside of the so-called black box, but to leave that kind of untouched. Also, and maybe even more important, the role of the human actor is often overlooked. Again, the black box sometimes is conceptualized without the human hands on the system, which when we looked more deeply into it, as with many of our collaborators in the MusAI project, we find human fingerprints all over that process at every stage along the way. But despite that decentered assemblage, nevertheless, we emphasize that we do push and pull like the potter and clay. So even though there is this kind of almost action at a distance, these time delays, these layers in the history of the process, there still is this dance of agency back and forth with those materials. Second theme that came out of this work was subjectification and space. And as I already implied when I showed you the setup at the beginning, concrete decisions that we made about the percussion setup, the microphone, and the loudspeaker also came out of our engagement with machine learning. And proceeded from a sort of guiding metaphor of what it would be like to place the listener metaphorically in the middle of the percussion setup, to hear the sounds that are normally only heard by the performer, usually only heard by the percussionist himself. And that led us to shape, quite literally with our hands and ears, that bespoke percussion sculpture, as well as the position of the microphone and 3D loudspeaker within that assemblage. But I also argue that so far there's been a lack of awareness of the embodied spatial presence of performers and instruments in AI research, in music and AI research. Much AI research in music seems to assume, if at all, if it acknowledges at all, mono or stereo listening situation, doesn't deal with whether we're listening through headphones, stereo loudspeakers, multi-channel loudspeakers. In other words, conceptualizing an almost disembodied listener rather than a listener situated in physical space. And this goes directly against many other fields of humanities and music scholarship, which have, for quite a while now, already acknowledged, as in this article by Georgina, the perspectival and relational nature of sound in the sense that it is always experienced from particular subjective and embodied physical and social locations. So this concept is not difficult for us as musicians to accept, yet I would argue it has not yet really played a major role in machine learning research for music. So my aim in this piece was to re-embody sound synthesis, and I approach that in two ways. One is by machine learning itself. As I'll show in a moment, I've trained a machine learning model on information from acoustic performers and their instruments. But a second way is also in the role of the listener. And in the initial performance of this work, as well as its companion work, which I presented in the composition seminar earlier, I asked the listeners to stand and move in the space when they experience the composition, and in effect to curate their own listening experience. So that's another way I'm hoping to re-embody machine learning in space. So just a word about the data. This comes from research at Technische Universität TU Berlin by Stefan Weinzierl and colleagues. And they invited 41 acoustic modern and historical instruments and their performers into an anechoic chamber, recorded them in a surrounding sphere of 32 microphones, and used that data recorded for every note of every instrument at 2 dynamic levels to model ambisonic spherical harmonic representations of the 3-dimensional wavefront of those instruments. So that's just on the right, a visualization from my patch of the data for that harp player on one of the notes that she's played. In the live performance, we wanted to, in a way, make an analogy to that study live, and we used a spherical three-dimensional microphone array, the Eigenmic on the left, and an icosahedral loudspeaker array, the Eco, on the right. And the Eco, unlike a more common ambisonic surrounding loudspeaker dome, is an object positioned in the space with the listener, which suggests an analogy to an acoustic instrument, which also radiates in a complex three-dimensional pattern. And so through machine learning, I'm hoping to quote unquote teach the Eco to radiate in space in a related, although obviously not exactly the same way. Finally, a third topic that emerged from this work was improvisation. Improvisation has been an important part of my compositional practice in terms of developing material with performers, but actually the presence of ML in this process led to a significant change in the way that I made the score, in particular incorporating a lot more opportunities for both computer improvisation and live human improvisation in and between the notated score. So in a way, work with machine learning challenged my own creative background and identity in new ways. As with many of my other works, the process began with transcribing improvisations by the performer, the radical personalization I mentioned earlier, which represent a kind of crystallization of the performer's labor and creativity. I then transcribe that to create a detailed notated score, and as the performer reinterprets that in concert, the computer improvisation agent analyzes and then generatively resynthesizes a computer improvisation. That doesn't sound good. But importantly, this is all aesthetically situated. So even though I may describe the process through words that on the surface could appear objective, like transcription, actually they're anything but objective. Every step is highly creative and subjective and very much sculpted and or biased by my own background. For example, Maxime and I were obviously drawn to a very noisy sound world in our choice of instruments that you saw earlier. This led to particular choices for machine listening, what kinds of audio descriptors we would use to analyze the data and therefore train the machine learning agents. And those particular choices led to very noise-oriented kind of computer improvisation. So we could call it a computer noise improvisation, which might differ from work another artist would do with related tools. Back to the performance, and just to parenthesize, so the first version of this score, I appeared in the studio with Maxime, fully notated in every detail. And as Maxime flipped through the pages, he slowly frowned, realizing that while the computer was given the opportunity to improvise and generatively produce material, he was not going to be allowed to respond in real time. And so through discussion, I realized very quickly that this was not going to work, and I ended up, in a sense, cutting holes in the score for Maxime's live human improvisation. So this very much challenged my own background and previous practice, but was absolutely necessary for the work with machine learning. And something that Artemi has also referred to in the presentation earlier, this led to what I find is a somewhat novel juxtaposition between composition and improvisation, where the lines are blurred between the passages in the work that are improvised and those that are composed. In the example you heard, there were both. Anecdotally, I find that listeners do not easily distinguish them, although I think it's interesting to ask listeners to think about that. At which moments was the performer improvising live, at which moments was he following a very detailed score. But I'm pleased that that is not obvious and poses challenging questions about what those two practices mean. Just a very brief visual. The initial improvisation, which ended up becoming the source material for the work, was actually the first time in Maxime's studio that we built this. And for me, it was a special moment watching Maxime kind of explore these instruments, this sculpture for the very first time. And so I recorded that, and that became the improvisation that I transcribed to make the whole score. Just let you see a brief moment of that. You can see very clearly how he's coming to terms with, making himself familiar with this new instrument that we've built together. Just a brief view of how that looks in the score itself. So this is a page from a bit earlier in the composition than the excerpt that I played. And we can see on the second line an example of my transcription of some of the improvisation you just viewed. And I've done that through a combination of max patching, subjective editing of the output of those max patches, and notation into a score. Then in the third line, the computer has been trained on that performance live and now proposes a generative improvisation based on that material. And then a few seconds later, the rectangle, the black rectangle on the third line represents an invitation to Maxime to respond with his own human improvisation. So I've specified which instruments he might use, but other than that, I've left open how he responds within a given duration. So that's the end of the first half of the presentation, but we thought it might be a good moment to stop for any immediate questions, if there's anything that you very quickly would like clarified. Otherwise, we'll have a much longer Q&A at the end after Artemi's spoken. But would anybody like to jump in with a brief question at this point? No? Shall we save that for the end and invite Artemi to continue? Thank you.
Oops. That is not good.
Mute it on
Um,
Zoom.
yeah. We don't need operator. Okay. Can everyone hear me here and online? Let's.
Oui.
Great. Excellent. Great. So I would like to start the presentation of my case study with a description of the musical work that was the product and object of this research, Bias 2 for piano and interactive music system. On the screen, you can see the main page of the score. This is an A3 page containing 7 clusters of musical actions which have been grouped together based on their timbral similarity. These musical actions involve various string preparations, which you can see right here, as well as extended playing techniques, mainly inside piano playing techniques. Here are what some of these sounds sound like. So here are some examples from cluster 1. That did not work. Moving on to cluster 3. Cluster 4 and 6. So the pianist in this piece can transition freely between any of these clusters, and a recurrent neural network actually tries to learn how performers navigate this timbral topology, how they create musical form out of these somewhat abstract, partially notated musical actions. So each second of the performance, this recurrent neural network, this RNN, predicts how the performance is likely to continue. What timbre is likely to follow next. And if this prediction differs from the musician's current audio input, the computer music system responds by playing back pre-recorded samples of the cluster predicted by the RNN. Importantly, the RNN in this piece is trained on data collected from all performances of the piece to date. So it is trained on the work's entire interpretative history. This is what the data used to feed this RNN look like. It's just a sequence of numbers. And this sequence of numbers represents an entire performance of the piece. So each number in this sequence corresponds to 1 second of audio and represents one of the 7 timbres in the score. 0 represents silence or background noise. These data are actually generated by a second machine learning algorithm, a feed-forward neural network, performing a rather straightforward machine listening task, which involves assigning incoming sounds to one of the 7 timbres in the score. So this feed-forward neural network is performing a classification task. This machine listening algorithm has 2 functions in this piece. The first is obviously to generate these logs of individual performances, which are later used to train the RNN. The second is to match different timbres with different types of digital signal processing. So these data generated by the machine listening algorithm are fed into the RNN, which then learns to predict the formal development of future performances of the piece. In reality, this RNN learns to generate similar sequences of numbers by predicting one number at a time. And this is quite similar to applications of RNNs in text generation, where these algorithms are used to generate text on a word-to-word or even character-to-character basis. As I mentioned before, each performance of the piece, the RNN is trained on the work's entire interpretative history. So bias 2 is the product of distributed and collaborative musical creativity. Creativity in this work is distributed among human and non-human actors, but also in space and time. The performer here is set in dialogue with the work's interpretative history, with interpretative choices made by others in the past as mediated by processes of datafication and machine learning. Another theme explored in this piece is the ontology of the musical work and the relationships among its various instances, which in this case include the score, the performances, the code, and of course, the data. So bias 2 could be described as what Georgina Born terms a provisional musical work, which both retains and blurs the traces and boundaries of individual and collective authorship. Finally, another theme explored in this piece and the research on this piece are critical insights into AI and machine learning in particular, gained through artistic research, through practice-led research. One such critical insight concerns data materiality and semiotics. Training the feed-forward neural network, the machine listening algorithm used in this piece, involved an iterative process of data collection, data pre-processing and analysis, and of course training and testing. From a technical viewpoint, this process aimed at preventing overfitting and improving the neural network's ability to generalize on new unseen examples. However, this process also yielded some tangible insights into the materiality of data. One such insight concerned the mediation of the various microphones used to record the training examples. So, for instance, training the neural network on data collected with a single microphone rather unsurprisingly led to overfitting, meaning that the neural network would actually perform quite well when tested with the same microphone that had been used to record the training data, but it was actually performing very poorly when tested with any other microphone. Of course, overfitting is a very common issue with machine learning algorithms. However, I do think that it's worth pointing out that it highlights an inherent tension between small data artistic approaches and the reliance of machine learning algorithms on big data. The technical solution to the problem of overfitting generally involves collecting more data, and preferably from different data distributions, which in this particular case meant recording examples using a variety of different microphones as well as different pianos. However, driving this iterative process of data collection, training, and real-time testing were qualitative judgments. For instance, judgments about the classification errors made by the neural network and the types of examples that needed to be added to the training set in the next iteration in order to mitigate these errors. So these judgments actually add to the contingent materiality of the data set used to train this neural network, and also highlight the processual nature of data. Now, far from being a purely technical concern, the classification errors made by the machine listening algorithm in this piece are actually aesthetically relevant. So, for instance, a false recognition of a certain timbre during the performance will obviously lead to a differentiated coupling between acoustic sound and digital signal processing technique. In many cases, I actually found that these differentiated couplings added unpredictability and interest to the interaction between the musician and the computer music system. So this is not something to be avoided. Beyond that single performance, over the work's interpretative history, these classification errors obviously feed into what the RNN learns and predicts, causing it to forge false associations between different timbres and leading to some extremely interesting, unpredictable, emergent, and idiosyncratic behaviors. So the objective of the data collection and training process I just described was not necessarily to produce the most accurate classification model possible, but rather to use data curation as a means of steering the behavior of the computer music system in a direction that is aligned with my own aesthetic values, which actually include unpredictability or indeterminacy. So yeah, in this context, data were actually, or classification errors were actually viewed as constitutive of complex behaviors along the determinacy-indeterminacy spectrum, rather than through the lens of optimization narratives. The analysis of the digital audio signal using standard music information retrieval tools, such as MEL frequency cepstral coefficients, or MFCCs, obviously added another layer of mediation through processes of mathematical reduction and abstraction. As part of the compositional process for this piece, I actually conducted a small experiment which involved feeding analyzed recordings of the musical actions contained in the score into a k-means algorithm. This is a clustering algorithm used to group data points together based on their similarity and proximity rather than some labels. The goal of this experiment was to compare the clusters produced by this k-means algorithm to the ones I had created in the score. And rather unsurprisingly, the two deviated significantly, which highlights the agency, the mediation, and the non-neutrality of music information retrieval tools. Finally, the decision only to include examples of a single timbre at a time in the dataset means that when performers superimpose sound material from more than one of these clusters, the machine listening algorithm is unable to make accurate predictions. As I mentioned, this has led to some, in my opinion, extremely interesting emergent behaviors. In fact, I would say that for me, this is perhaps the most interesting feature of the interactive music system. All these examples underscore the material and processual nature of data and challenge common understandings of data as natural, neutral, objective, and collectible. As Annette Markham observes, the term data is in most common usage associated with something that one gathers, hence is a priori and collectible. Data are potentially informational, yes, but as operationalized in most of the social or natural sciences, function fundamentally as discrete objects that can be located in time and space. The problem with this conceptualization is that it remains categorically different from, and in a sense opposed to, the very idea of process. In fact, even terms such as data extraction and data collection, which I used repeatedly in this presentation, are indicative of a rhetoric of what Bowker and Starr call naturalization, or of what Harding refers to as the neutrality ideal. They detract from the material and processual dimensions of data and their embeddedness in larger cultural and social assemblages that determine what is rendered visible and invisible through processes of datafication. In an effort to unveil the politics and values enmeshed in data, Lindsay Poirier actually proposes 3 modes of reading data sets, which are derived from semiotics: a denotative, a connotative, and a deconstructive reading. A denotative reading focuses on the literal meaning of the numbers. A connotative reading aims to situate data sets within specific historical contexts. A deconstructive reading examines what is left out of the data, what is rendered invisible through processes of datafication. So returning back to my data example, I would like to attempt a connotative and deconstructive reading of this example, focusing on the aesthetic values rather than the politics enmeshed in this data. As I already explained in the denotative reading of these data, the numbers here represent clusters of sounds which have been grouped together based on their subjectively perceived timbral similarity. So given that what is represented by this sequence of numbers is essentially musical form, this suggests an understanding of form as a function of timbre, or a prioritization of timbre as an articulator of musical form. So this information immediately places the work within specific music historical and aesthetic contexts. For instance, the tradition of the prepared piano, but also timbre-based as opposed to pitch-based music. Not only the semantics of the data, but also their quantization is suggestive of aesthetic values and their crystallization in the data. For instance, here, for each second of audio, only the predominant timbre during that second is recorded in the data. This effectively limits the frequency of musical changes, the maximum frequency of musical changes proposed by the computer music system to 1 per second. So this was a purely aesthetic decision. It was a compositional decision meant to impose a constraint on musical form by preventing the computer music system from proposing too frequent musical changes, or at least what I subjectively perceived as too frequent musical changes. The fact that these data were generated by another machine learning algorithm performing a machine listening task obviously means that this process of datafication of individual performances of the work is prone to error. And in fact, as I explained, the work very much explores the aesthetic potential of classification errors made by the machine listening algorithm used in the piece. Finally, crystallized in this data are the performer's interpretative choices, and this suggests a destabilization of the composition performance or composition interpretation binary. Each interpretation of this piece is at the same time an act of co-authorship. And indeed, past performances of the piece by pianists Magda Mayas and Ksenia Pestova-Bennett, as crystallized in the form of data, are an integral part of this composition. Shifting perspectives from a connotative to a deconstructive reading reveals the processes of framing and demarcation involved in the data-making process. For instance, due to the way that data are quantized here, potentially complex musical textures consisting of multiple alternating or even synchronously sounding timbres are reduced to a single timbral category. Of course, this focus on timbre is itself a process of demarcation. It leaves out a large number of alternative framings and perspectives, such as pitch, duration and rhythm, dynamics, phrasing, and so on. Also left out is spectral information rendered redundant by the particular music information retrieval tools used, which in this case was MFCCs. Finally, one last process of demarcation concerns the medium of sound itself, this focus on machine listening. So rendered invisible through this isolation of the oral from the visual, or I should actually say from the embodied experience of the performance, are the choreography of the performer's movements, the material conditions of sound production, for instance, the various objects that the performer uses to perform various extended techniques, and other inaudible aspects of the performer's interaction with the computer music system. For instance, moments in which the performer visibly changes their mind about what to do next after a musical change has just been introduced by the computer music system. These connotative and deconstructive readings of the data used to train the RNN reveal that data making in this process was very much a compositional act. However, aesthetic decisions in this piece did not just take the form of data making or data curation, but also of hard-coded rules and framing generative processes. For instance, while interacting with the computer music system myself early on in the compositional process, I observed that the computer music system seemed to be oblivious to the social dynamics of the interaction. Essentially, the RNN tended to make predictions that did not match my actions in that moment, and so the computer music system kept proposing sound material in the form of playback of sound files. This resulted in what I perceived as a very unbalanced musical interaction. This is partly a byproduct of this isolation of the sonic from the social through processes of datafication, but it's also a byproduct of the application of a model usually used for text generation, which involves generating a single stream of information, to music, which consists of multiple synchronous streams of information and the complex and highly convoluted relationships among these streams of information. So in order to counterbalance this dynamic, I felt the need to intervene by introducing some hard-coded rules that allow the computer music system to track its moment-to-moment decisions to either follow the musician's lead or propose different sound material. In the current version of the software, the computer music system calculates this leading to following ratio and tries to maintain a balance between these two. The computer music system also had trouble sensing the performer's intention to end the performance, and in fact, it still has trouble sensing that. Again, this is partly due to the fact that this intention is not necessarily signaled through timbre per se, but mainly through other aspects of sound, for example, dynamics, in some cases, the density of musical events, and so on. Similarly, here I intervened by introducing a hard-coded rule that biases the computer music system to respond to silence with silence after an elapsed time of 12 minutes, which is the recommended duration for a performance of this piece. At this point, I would just like to play an excerpt from the premiere of the piece by Magda Mayas at ZKM, Zentrum für Kunst und Medienkultur in Germany. Let's see if this will work. Thanks. So wrapping up, I think that both of our case studies showcase that material engagement with machine learning in the context of the compositional process involves a two-way movement between aesthetic commitments and the perceived affordances of machine learning algorithms. So our aesthetic commitments and languages were in fact shaped by this engagement with machine learning algorithms and data. For example, in Aaron's case, this led him to introduce blocks of guided improvisation into an otherwise thoroughly notated musical score. However, at the same time, our approaches to data and machine learning algorithms were very much shaped by aesthetic commitments and research questions. For instance, a commitment to engaging critically with the materiality of machine learning algorithms and data led us to challenge common understandings of machine learning tasks as closed-ended tasks oriented at optimization, and instead reframe them as open-ended aesthetic experiments. Our distinctive aesthetic commitments led each one of us to engage with a different theoretical framework relevant to our own compositional practice. Aaron's work explored how engagement with machine learning differs from material engagement with other music technology tools. My work drew from critical data studies to reflect on cultural and aesthetic dimensions of data and explored an additional material dimension with particular relevance to machine listening. However, our projects also shared a common epistemological stance. Aaron also already mentioned it, Georgina Born's post-positivist empiricism, which involves amending and extending theory through empirical research, or insights gained through empirical research. Crucially, our artistic research perspective, our practice-led perspective, played a central role to generating these insights by allowing us to engage in critique through direct material engagement with algorithms and data, rather than from a theoretical distance. As far as the distinctive qualities of machine learning as a music technology tool are concerned, we think it's important to acknowledge the heterogeneity of machine learning algorithms and the multiplicity of the term machine learning, which really seems to resist any tendency to make generalizing, universalizing claims about machine learning. Secondly, I think that all three of us were actually struck by the similarities between interactive music systems using machine learning versus those that do not. And indeed, we found that most of the differences were a matter of degree rather than kind. One such difference is that machine learning seems to intensify the density of actions and to multiply the phases of creative decisions, from recording sessions to the selection of features for machine learning to the programming, training, and testing of machine learning algorithms. Additionally, these decisions seem to produce consequences that were not direct and immediate, but rather involved delays and iterations in the way they affect other components of the assemblage. One last difference concerns the black box mediation of machine learning algorithms. When working with machine learning algorithms, one cannot directly access or manipulate the mathematical functions learned by these algorithms, but only the data from which these functions are derived. So this introduces an additional layer of mediation in comparison to interactive music systems that do not use machine learning, that are based on programmed rather than learned input-output mappings. So working with machine learning involves delegating a higher degree of creative agency to software components of the assemblage, as well as displacing the locus of composition from designing and determining relationships between inputs and outputs to simply influencing those relationships in indirect and nonlinear ways through processes of data making. Yes, I would like to thank the pianists that participated in my project, Magda Myers and Ksenia Pestova-Bennett. And yeah, I think this concludes our presentation, and we would be happy to take your questions now.